Good morning, children. So, in the last class, we have learnt what is a polynomial, basics of algebra, even different types of polynomials based on terms and exponents, degree. So, depending on terms, we are having monomial, binomial, trinomial, polynomials. Depending on the degree, linear equation, quadratic equation, cubic equation, biquadratic, like that. Okay. So today let us move to the important topic, zero of a polynomial. What is the zero of a polynomial? So in the last class itself I have explained the one more concept, zero polynomial. Zero polynomial is different from zeros of polynomial. Okay. So what is this zeros of polynomial? So we already know that a polynomial will be having a variable, isn't it? So the variable value will become something so that the whole expression will become a zero. So the value of the expression, value of the polynomial, if it becomes a zero by substituting certain value for a variable, such a value is called as a zero of a polynomial. Here I took one polynomial, children. This is a polynomial, 5x cube minus 2x square plus 3x minus 6. Okay. Now let us substitute 1. X value as a 1. See, wherever x is there, here x, here x, here x. In all those places, you have to substitute 1. Are you getting? Now, 5 will be as it is. X place what I said, 1 you have to substitute. So, 5x, there is an exponent 3. Here also you give the power as 3. Again, minus 2 as it is. X value is 1 square plus 3 x value 1. And this minus 6 will be as it is. Now, let us move to the simplification. 5 as it is, 1 cube is. 1 cube means what, children? 1 cube is nothing but 1 into 1 into 1. So, how many times you multiply 1? The final product will be 1 only. So, 5 ones are 5. Here also 1 square is 1. 1 into 2 minus 2. 3 ones are 3 minus 6. Now, after getting this, which are having positive sign and which are having negative sign, you check it out. See here, plus 5 plus 3. So, add them. It is plus 8. Minus 2 minus 6, that is minus 8. So, plus 8 minus 8 get cancelled. Your value will become 0. So, here x is equal to 1 is a 0 of the polynomial. Now, by substituting 1 in the expression, the whole expression has become a 0, isn't it? So, this value by which this polynomial has become a 0, this value is called as zeros of the polynomial. Okay. It may be a single value or more than single value also. Not only this number, still more numbers also can satisfy this condition for this polynomial. Okay. Now, let us go with the some more problems related to the topics. Sometimes the problems will be in this manner, children. See the problem here. Check whether minus 2 and plus 2 are zeros of the polynomial x plus 2. This is the question. Now here p of x is what? X plus 2. So we had to check for these two values. They only given the values here. Which are that values? Minus 2 and 2. First we will take minus 2. So if you want to take minus 2 means x should be minus 2. Substitute that value. Now in this expression, this is the expression we are having. Here where x is there you have to substitute this value. So first value itself is x. So in the place of x, minus 2 you substitute and plus 2. See, minus 2 plus 2 get cancels, it is 0. So the one more value they have given is plus 2. Let us go with the plus 2. So what is the expression? x plus 2. In the place of x, 2 plus 2. Both are positive. 4 it becomes. So, by this what we can say, minus 2, by substituting minus 2 we got 0. That's why minus 2 is a 0 of the polynomial, but plus 2 is not a 0 of the polynomial. Okay. So, by all these things, so what is zeros of polynomial? What are its characteristics? Let us learn it out. So, the important points. What is that? A 0 of a polynomial need not to be 0. Sometimes it may be 0, but not always. Okay. Need not to be in a 0 only. The second point, 0 may be a 0 of a polynomial. I already said, even sometimes 0 itself become a 0 of the polynomial. Then, if your polynomial is linear means power is 1, then it has one and only one 0 of a polynomial. It is not having a more than one value. But if it is other types of polynomial, you will be having more zeros. Okay, more one zeros you will be having. So, these are the characteristics of zeros of polynomial. Now, let us move to the exercise related to the same topic, children. Okay. So, what is the topic? What are those problems? Let us discuss. So, the first problem is here. They will give in this way. Find P of 0, P of 1 and P of 2 for each of the following polynomials they have given. They will only give the polynomial. For that polynomial, you have to substitute these values, which are 0, 1, 2. Are you getting? Polynomial will be given. In that polynomial, you have to substitute these values. Which are the values? 0, 1 and 2. First, P of 0 we will take. That means wherever y is there we have to take y value as a 0 here. Getting? So, y square 0 square minus in the y place 0 plus 1. So, whatever you add for a number, 0 if it is added, subtracted, the value of number will not be changed. So, number is here 1. So, you are getting answer as a 1. Now, let us move to one more value, which is a one more value, P of 1. That means here y is equal to 1. So, y square means 1 square minus y is equal to 1 plus 1. Solve it out. 1 square is 1 minus 1 plus 1. Here plus 1 minus 1 get cancelled. Your answer will be 1. Now, P of 2 we have to find. That means whenever where y is there you have to substitute 2. So, y square means 2 square minus y means 2 plus 1. Simplify it. 2 2s are 4 minus 2 plus 1. So, positive numbers, add them. 4 plus 1, 5 minus 2. So, 3 is the answer. Have you got? So, what is the answer here? 3 is the answer by subtracting. Now, here we can find all these three values are not zeros of this polynomial. Clear? Now, let us move to the next problem of the exercise. The one more type of problems you will be having is verify whether the zeros of the polynomial indicated against them are true or false. Okay. So, this is the first problem. P of x is equal to 3x plus 1. So, x value they have given as a minus 1 by 3. You have to check whether it is a 0 of a polynomial or not. How to check? Substitute the value. If you get the final answer as a 0, then it is a 0 of the polynomial. If you are not getting, then it is not a 0 of the polynomial. So, this is the expression 3x plus 1, x value is minus 1 by 3. That means wherever x is there, you have to substitute minus 1 by 3. 3 as it is in a bracket minus 1 by 3 plus 1. 3 get cancelled, minus 1 plus 1. See here opposite sides. Plus 1 minus 1 is 0. So, here this value is a 0 of this polynomial. Okay. Now let us go with the one more problem of the same exercise. So p of x is equal to Lx plus m. X value they have given as minus m by L. What is x value? Minus m by L. So p is equal to, in x place what you have to substitute? This value m by L. L as it is. X value is minus m by L plus m as it is. See, L get cancelled. So minus m is left plus m. Plus m minus m also get cancelled. It is 0. So even it is 0 of the polynomial. Okay. Now let us move to the one more problem. Third problem of the same exercise. So this is the question. P of x is equal to 3x square minus 1. And x values are minus 1 by root 3 and 2 by root 3. Are you getting? Minus 1 by root 3 and 2 by 3. Now, first we will substitute this value. Two values are here, comma is here. So, this is one value and this is one value. First we will substitute this. So, 3 as it is, in the place of x, what we have to substitute? Minus 1 by root 3 whole square. Minus 1. Just check here, my children. 1 by root 3 minus 1 by root 3 into minus 1 by root 3 will be what? Minus into minus plus. 1 1s are 1. And this is root 3 whole square. Square root get cancelled. You are getting 3. So that is, I wrote this 3 as it is. The simplification of this is 1 by 3 minus 1. 3 get cancelled. 1 minus 1. So 1 minus 1 is what? 0. Yes, it is a 0 of the polynomial. Now let us move to this. One more problem. One more value they have given now, 2 by root 3. That we will substitute. So x value 2 by root 3. 3 as it is. In the place of x, 2 by root 3 whole square. Here also 2 by root 3 into 2 by root 3 whole square means you can write it as a 2 times. 2 2s are 4. Root 3 into root 3 is root 3 whole square. Square root get cancelled. It is 4 by 3. So 3 as it is. The simplification of this is 4 by 3. 4 by 3 minus 1 is here. Here also 1. See, 3 get cancelled. 4 will be left. Minus 1. So the answer is 3. Okay. So it is not a 0 of the polynomial. Now let us move to the one more problem of the exercise. This one. Find the 0 of the polynomial for p of x is equal to x plus 5. That means already they have said 0 of the polynomial. That's why p of x you take as a 0. Okay. So p of x, x plus 5 they have given. This value you have to substitute as a 0. So send plus 5 to this side. So x value will be minus 5. So for this value, this will become as a 0. Okay, got it? Now